We're still working on these performance considerations. We started, I think, 2-3 episodes ago with indexing, and we started with storage. I gave some storage recommendations. And if you just happen to watch this now, I mean, we're recording this, so if you're watching this on YouTube, you may just have to go to some previous videos where I talk about storage recommendations and indexing options, functional index, and JSON search index. So we learned with functional indexing that this is limited to pulling out scalar values out of your JSON. So if you have an array of values, then this is not so easy to index using functional indexing. We presented the JSON search index in the last series of this AskTOM Office Hours. And today we're gonna do materialized views, which is also one nice way of improving the performance. So we have this JSON table row source, which allows you to iterate over arrays and pull out values inside your JSON. So if you have an array, then every item in this array generates its own row, and that way you get scalar SQL values. And values in the JSON are projected out as separate columns, so the result of JSON table is basically looking like a plain relational view. Now I have to move a bit so that the light sensor kicks in and I get light again. 1 second. Okay, there we are. All energy saving here. So JSON table is just a row source. So if we use a materialized view on top of that, then the actual values are stored on disk and we don't have to do the parsing of the JSON over and over again. We can jump straight at the values. So it can be seen as some sort of pre-computing the JSON processing. And by adding secondary indexes on the view columns, we're able to also drive a where clause query using these indexes. And with this fast refresh option, we show how we can only recompute the JSON on the base data that has changed. So this is ideal for many use cases. This is quite common. We see a lot of customers using this. It's ideal for reporting or business intelligence or warehousing use cases, but you may also use it for just plain JSON processing if performance is such that you benefit from this. So we're trying to also make use of indexes in our evaluation of JSON value and JSON exists. This is something I can show today because I'm running still on an 18.3 database, and that's a feature we've added, I think, in 19. But this is just a heads up that if you have such materialized view, what I show today is that we query the materialized view directly, but in 19 and later, we gonna look if such materialized view is present and we do a rewrite of the query automatically. So let's jump then, this is the slide part, let's jump then at the actual interesting thing, the demo. And I think now I have to share my Chrome here. Can you see this?
Yes.
So this is on Live SQL. So this was the first series which covered the indexing and functional indexing. Then this is the last one. I just finished this 3 days ago. People asked me when this was available on AskTOM. Said it would take a week. I was wrong. It took 3 weeks. So now this is available. It's the January 8th episode. So the script I've shown there, you can now play with it. And even the one that I'm going to use today, it's already on there. So it's JSON and materialized view, and it's the February 12 office hours. So if you click on it, this script should be public now. Then these are the steps we're going through here. So I've added some comments. But I prefer to use a SQL developer for this because then we can go through this step by step. And again, if you have questions, there's not so much content for today, so we don't have to rush through it. If you have a question, just put it in the chat and Blaine will interrupt me and we can then discuss your question. And I think there will also be plenty of time at the end where you could ask me anything related to JSON or Oracle or life in general. So let's get started. So I'm going to share my SQL developer now. Okay. Blaine, can you see this?
Yes, I can.
Wonderful. So we're using the same data that we've used last time to motivate the JSON search index. We have a table that I called zoo, and we're going to store some information about animals as JSON. So I use the data type varchar2 4000, but I could also use blob or clob. I was just lazy and picked some varchar, and I have the check constraint here just to tell the database that whatever I insert there should be checked for JSON. And that table here now also has an ID, which we had last time, but now I explicitly called this a primary key. This will be important a bit later. So every JSON document here is identified by a primary key. So let's create this table. And I'm inserting a few animals here. So every animal has a name, a species, and then they have a field called food. And this is what they like to eat. So our dolphin likes to eat fish. And our dog likes to eat dog food. And then there is our cat, where it has an array of meow and mix, which is an intended mistake. It should have been meow mix, but I just cut this into two items here. I think this was for last time with a text index. So I think this, it's not so important that this is meow and mix instead of meow mix. It was important last time. Then we have our giraffe. Did I insert the giraffe? Let's see. Should raise. Yeah, I already inserted it. This is Melman. It's a giraffe. We have not figured out yet what the giraffe eats, but we're going to figure this out later today, and we do an update. And then we have our lion here, Leo. And he has now a true array of food items that make sense. So our lion likes to eat giraffes, but we tend to run out of them. So we also give him cat food, meow mix. So this is an example here where you have an array of multiple values, and this would be hard or actually impossible to index with a normal B-tree index. So if you have one value, like fish or friskies, or no value at all, like with our giraffe, you could easily create a JSON value-based index with error on error, null on empty, and this index would be picked up. And the reason is that the B-tree index or the functional index relies on one value being returned by the function. But for our lion here, it would fail because we have two values. And for now, the current implementation of the functional index does not support that. Okay, so we've inserted the data. Actually, let's do a commit just to be safe. Should work without. And now we use JSON table to project out the values. So I'm just running this. We can take a look at the result and then see how we get there. This is the result. We see the ID, we see the name of the animal, we see the species and what they like to eat. So how does this work? We're in our select list, we're selecting the ID, quite simple. And every column that our JSON table returns. So JSON table here, the result of JSON table is aliased with JT. JT returns us a few columns, and those columns are all selected in the select list. So now let's move to the from clause. We're selecting from our base table, and then we do a lateral join with JSON table. We feed in the JSON, and we give it a path expression that defines the number of rows. So dollar means we're not navigating to any array yet or to any field. We're selecting the entire document. So the dollar is basically it's the starting point. You could have $.a.b or $.name if you want to navigate at this step, but here we're just selecting the entire JSON data, so to say. And relative to that path expression, we evaluate these, or we want these columns. We want the name and the species. So they are part of the column list, which is selected by jt.star, and we see here that we have the name and the species being selected. And now we iterate over this nested array. So food is an array, or could be an array. Sometimes it's not an array, but it could be an array. So we're iterating over it. And then for each item, we project out a new column called food. And because the food is already a string inside the array, this relative path expression can also be just a dollar. I mean, this looks a bit complex if this is the first time you see a JSON table statement, but if you play with it a bit, I think it's getting easier fast, and that's also what you can do on the live SQL. So all this here is on live SQL as of now, so you can play with it. So this is the short syntax. So you see this for name. We don't give it a path expression and not a data type. This is some convenience shortcut that we did. If you look at the standard, this is now the same expression in the full syntax. You would say that this is the column name, this is the data type. So if you don't provide a data type, we pick a varchar 4000 as a data type. And here I picked a shorter data type. There may also be columns which are non-textual, where let's say it's a number or a date or something like this. So you could pick these data types here and override the default. And then this is the path expression, which gives you the value. So sometimes you want the column name to be different than the path expression. So let's say instead of name, you wanted to give it nickname or something, then you could just use different strings for the path and the column name. Versus here in this short syntax, the path is derived from the column name. This is why I put this in double quotes, because this is case sensitive. So if I just written name here in uppercase, then it would not have matched the field name inside the JSON. Okay, so if I run the full syntax, it looks exactly the same down here, because the only change is basically the varchar 4000 default is a varchar 32, but the SQL developer here takes care of the proper printing. So now, given this JSON table, or let's just look at the results. So you see that each food item is generating its own row. So we have unnested the JSON. And for our lion here, we see our lion likes to eat giraffes and cat food. And the values outside the array are just being repeated. So it's the same, it's Leo the lion, and the ID is the same here. So we repeat the values outside the array. So this nested path can also be applied recursively. So if you have a complex JSON structure with multiple levels of nestings, or let's say sibling arrays on the same level, you just apply this nested path, and it will also unnest recursively. It just generates more rows then, and it will always repeat the values outside the array. So now we take the exact same query here, and all we do is we stash a materialized view on top of it. So now we create this materialized view. What does it mean? We run this JSON table statement, but instead of running it and just shipping the result to a client, we store this now on disk. So it's kind of now a table on disk, but it's a table that is depending on the JSON base table. So now if I evaluate this query, oh, I got to move again. The light got out again. Okay. Apologies for that, but it keeps me active, so I get some exercise while doing this. It's also good. So if I run this query and I want to find out what animals like cat food, then I can run this query against the materialized view easily. And if we look at the explain plan of this query, we see now that this is a materialized view axis, but it's actually a full scan of the materialized view. So this is the equivalent on a table would be a full table scan. So this is not so optimal. I mean, we haven't gained much here, but now if we create a index on the materialized view, then I can run the same query, and we see that if I run the query, this is now an index-driven query. So now going back to this entire motivation, we have learned in the first series of this presentation that the functional index cannot index array values. And we presented the JSON search index as one solution or one workaround to that limitation, but we also learned that the JSON search index typically indexes the entire document, which requires more space. There is a bit of a fan-out problem if you have documents with a lot of field names or a lot of values, and if you don't want to index them, it can be a bit wasteful. Here we learn now that using the materialized views, you are indeed able to use a B-tree index because the JSON table has taken care of unnesting the JSON and giving you scalar values. So if I also select the ID in this column, I would basically know which row is contains the value I'm interested in, and this is now a purely B-tree driven query. Was there something in chat, a question, Blaine?
The question is, can the materialized view be fast refreshable?
Oh, let's see. I don't know. Good question. Let's just continue. Maybe it comes. Okay, so what about refresh? Oh, this refresh, nice. Might answer the question. So now I'm inserting another animal here. This is our space dog, Leica. We insert our space dog. We commit our insert, and now I'm selecting all the names from my materialized view, and oh, it's not there. So something is not really satisfying here. I have my materialized view. I made a change to my base table, but my materialized view is not reflecting the change. So that is because I've chosen kind of a dumb materialized view where I have to explicitly call a refresh. And you see already this refresh takes a bit of time. And that is because it's refreshing the entire view. So it's not only running JSON table on my Leica, on my new row, but it's rerunning it entirely. So now if I execute the name, I see my Leica, but this approach is not really scalable, because you can imagine if you have several million rows and you just make a change to one row, like an update, or you insert one, and now you have to re-evaluate JSON table on the million rows, that this is getting quite slow. So this may be good in some cases, but not in this case. And again, I mean, this presentation comes a bit with a caveat. I'm not really an expert on materialized view and all the options they have. So you may want to read up about this if you really want to go into the details. But what I want to show is exactly what was asked right now. Can we do some faster refresh on this? So let's toss our slow materialized view. And instead, we want to have a materialized view that is smart enough to only update those pieces that are relevant. So for this, we need a materialized view log on our zoo table. So what is the materialized view log? This is basically a log that's being maintained and that keeps track of all the insert and updates on our base table. And for this, it's important that you have something identifying your rows in the base table. So for this, I've used this primary key. So remember, back here, I had the primary key on the column, and I also select the ID in my JSON table view. I think this could also work with row ID, but I've just used the ID here instead. And you can now imagine if you have an ID in your base table, and if you have an ID in your materialized view, it's relatively easy if you know these IDs have changed that you go back to the materialized view and only update those rows because you have a one-to-one relationship, so to say, or a one-to-n, but it's clearly defined what needs to be updated here. So now I have my materialized view log, and let's create, already dropped this, we don't need this step here. Let's create another materialized view, which I called fastMV. And this has this fast refresh option on commit. So there's also on demand, I think, and there may be other options. This is again where my knowledge is limited. I'm not an expert on materialized view, but we're now creating this view. The query is exactly the same, where it's only refreshing the things that got updated, and it's doing this on commit. So now we also create our secondary index on the food item. Now we look who's liking roots. Nobody's liking roots yet, but this was an index-driven query. And now we insert another. We do an insert, which is our elephant. Dumbo, he likes roots and tree bark. And if I rerun the query, I still don't see him. And the reason is that the view is refreshing on commit. So I have to do a commit here. And there may be statement level refresh. I haven't tried it. And this may be something that's not available on 18. I really don't know. But once I've committed the change, we see that it got immediately propagated into the view. And if I query it, this is an index-driven access. So we're basically just doing a B-tree scan and a B-tree scan on the food, and we get the ID back. And I could use this ID or the name. I mean, this is now the information I need to go to the, I'm querying the fast refreshed view, but if I have the ID, I can easily go back to my base table and pull out the JSON if I wanted. Was there another question in the chat, Blaine? Just saw it.
Yes, the question is, statement level refresh was introduced in 12.2. Should it work as well? Or so it should work as well. So
I think the answer would be yes. I knew it was introduced, but I didn't know which version it was. This is, I think, something we could try on, or that whoever asked the question could try on Live SQL, because that's version 18.3, I think. So it should work on 18. But no guarantee here. I have not tried it out. We typically, the customer engagement that I was involved, they all used on commit because the reader was another one than the writer. Basically, they had clients writing into the data, and then they needed some other threads that were querying to see the data, but they wanted it to be done after a commit. So I have not played with on statement refresh. Another question?
Just a comment, Live SQL is on 19.1.
Oh, it's 19.1. Oh, nice. Oh, cool. I didn't know that. When was the update? This must have been recent. Okay, where were we? We were here, right? So now let's do an update. So we finally found out what our giraffe likes to eat, and it is this year. How do you pronounce this, Blaine? Is it acacia?
Acacia, I believe.
Acacia. Okay. Yeah.
If you want to see what it looks like, that's what my floor in my office is made out of.
Okay, I'll take a look after this. So we do this update here by using merge patch, and that's actually something I could imagine we do in the next AskTOM Office Hours, that we talk a bit about update possibilities. This is just one way of updating it. So we basically provide a key value pair. Food is acacia, and we merge it with the existing JSON, which is in our jcall column. And ID equals 4. This is Melman. This is our giraffe. So I run this update, and I do a commit. And if I query it, I see that it is. So yeah. So what I've shown here is that if you query the materialized view, you get it updated, and it's fast refresh. It can be using index path, because you can have an index based on the on a materialized view column. And what we try on, it might already work then if live SQL is 19.1, because I am here on an 18.3 database on a Docker image on my machine. So this wasn't working. So this is something that probably should work on 19, where if we see a JSON exists on a base column, then we try to rewrite it to a materialized view if one is existing. So that I need to check on live SQL, and I'll change the script if it works. But that's a work item for me.
Couple things up in chat.
Yes.
Yes, but statement level refresh has many restrictions regarding the form of the query, so we should check whether it is compatible with JSON table.
Yes.
Followed by Ludith, I think since commits work on statements, since on commit works, on statement works as well, and then not exactly on commit has much fewer restrictions.
Okay, cool. Yeah. So see, that's why this is great here. I can learn. I really we had a few customers who are using this, but we worked with the materialized view team to kind of get them the best setup. So I think I need to, yeah, we could do on statement. We can do this. Let's just go back and but again, this is, I think I'm on an 18 version here. So materialized view, and now this is on statement.
You're not sharing your screen at this point.
Oh, okay, yeah, sure. That's let's do this. I do now, right?
Yes.
So I drop the materialized view, and I replace this with, gotta move again, light got out. This is actually good. This forces me to get up.
I should put something like that in my office.
Yeah, it's a good idea. Like every 5 minutes you have to get up and move. So this went through. Now that we don't really need, but let's just give it, let's just do it now. Dumbo is there, so we have to, we could just drop it or just insert another one. Let's just insert another one. Come on, guys. Someone has to put an animal in the chat now. Let's make this a fun exercise here. So I want to, so Blaine, you're telling me what to add. So this is animal number 8. So someone has a good name here. I took these from movies. Do you see something, Blaine?
Not so far.
Guys, come on. Famous movie animals.
Nemo, the clownfish.
Yes. What does a clownfish eat? Plankton? Plants? Water plants? Is that okay? Okay, let's give it a try. Okay, no, they don't eat plants. Blaine?
I think they do. I'm not sure.
We're so bad. We're so bad. Okay, so we inserted something. It took 3 seconds. That's slow. So now, I did not commit. Yeah, there it is. Appears to work. So now if we do a roll.
Yeah, they say it eats coral.
It eats corals. Corals, is that correct? So this was 8. Like this? Okay, I do an update. I have not committed, so now this should return nothing. And this should, yeah, works. Looks good. Let's see this. What happens now? Roll back. Corals doesn't work. Plants. Why did that work? Oh, because I did not commit. Okay, so there is no 8 basically. I've also not committed the first one here. Yeah, this appears to be working. So there's basically no 8 here. If I just do this, we should not be seeing Nemo because I roll back the insertion of Nemo as well. Nemo's out. Yes, no Nemo. Yeah, so it appears to be working. Thanks a lot. I learned something. Clownfish are omnivores, which you say. Yeah, cool. Awesome. Good. Any more questions here? Did I lose you guys? Blaine, are you still on? Did I meet
am.
you? Are. So that's the show. That's what I presented for you. I kept it tight. The message was that materialized views work quite well with JSON. And
so if you look at my camera, look right in this area, that's what acacia looks like.
oh, so you have to be careful that no giraffe ever gets into your room. Otherwise, they probably eat the leaves, right? They don't eat the wood.
I think they stripped the bark, if I remember, when I went to the San Diego Wildlife Park.
Okay.
Sure.
I think I should visit more zoos to learn about that.
I know if you go to the San Diego Zoo, they have a giraffe feeding station where they give you a little hay cube and
Yeah.
let you do that. My kids kind of like that.
Yeah. Yeah, I've been to the San Diego Zoo. It's pretty cool. But I don't recall seeing the giraffe. They had the ice bear behind a thick glass. It was very cool. Good. So I think we can get, if you have any other JSON-related questions or suggestions for new AskTOMs, I'm always open. What I plan now is to maybe have update options next time. So talk a bit about JSON merge patch and updates in PL SQL and stuff like that. If this sounds interesting, we could do that. If this does not sound interesting at all, just let me know and we do something else. I'm really quite open to that. Or also if you want to do, okay, one person said it's great, but put it in the private chat so others don't see it. Yeah, well, maybe let's do updates then next time. Okay, now it's public. Thank you, Gancho. Any other comments or questions before the light goes out again here?
That might not be a great idea for my office, come to think of it. The light goes out, I'd probably just go to sleep.
Yes, that's true. Well, I'm happy nobody came here and interrupted us, so this went well. just like a bunker without any window here. Good. If there are no more questions, I think we can conclude this here. And maybe I'll go and proceed and at least add a comment in the AskTOM. So all this you can, I'm just going to share this again. So you can go on Oracle Live SQL and you should be able, if you, let's actually try this out here. What happens if you just look for Json? Oh, there's quite a bit by now. JSON object. But these things show up. Okay, text contains. Oh yeah, this was the first one. Indexing. Search index. Where's the materialized view? It should. Wow, wow, wow. I didn't know we had this much stuff on there, but here it is. So you can either look for a materialized view or just look for JSON and scroll a bit, and then you can run this script. And I've added some comments here. Unfortunately, explain plan does not work that easily in Live SQL, so I had to create this workaround with a plan table, and then we do we basically do an explain plan which populates this plan table, and then we query out plan table. Well, that's okay. I mean, this is just 1-2 extra steps. Well, this is the exact same stuff, so you can play with this on Live SQL as of now. So this should be
comment in the chat about a problem with the previous example.
Regarding the example from the previous session, there is a logical problem with JSON which turns different results for this was a bug, I think. I think we fixed this. Didn't we discuss this last time you did? I think this was a bug on, I don't recall it. I can try digging up the email, but I was able to reproduce it on Live SQL about a month ago, but it was not reproducing on later releases. But I cannot tell you which one it was. I probably tried it out in our production labels. So this was not. This was clearly a bug. I think this was a text index. So the text index returned rows, but we didn't do the proper post-processing. So you were seeing. Yeah. Oh, you're saying like if you, we just saw the example with inserting like and querying for it without committing without a text index. So the text index is, I think by default, the JSON search index is by default you need to commit it. So if you don't commit it, you don't see it. And that is, I think, just something you have to keep in mind. Maybe you could, if you don't think we have resolved this, maybe you could shoot me another email, and I try to reply to it today. Is that okay? Or should we open the last one? I mean, I could go back to. It's easier to go to my scripts, search index. This is the last one. So, let me share. Do I still share my browser?
Nope, we're looking at your pretty face.
Thank you. What about now?
Yep. Now we can see the browser.
Okay, so this is last one's office hours. So Judith is talking about Leica Here it is. So this is, we're inserting Leica, and we don't find her because the index has not been committed yet. So now we commit it, and now we see Leica. Is that the logical problem that you're referring to, that this query here returns no row if you have an index, and it returns a row if you do not have an index? Is that computed?
That's it exactly.
Yes. I think this is a property of the JSON search index, which has onCommit semantics. Do we have onStatement yet? We don't have it on 18. I'll take this as a work item for next for the next office hours to see if we have onStatement there as well, already available or in the doing. But I don't think we have it now. So this is really something you have to be aware of, or you have to work with, that the JSON search index has this onCommit behavior. That is correct. So it is, I agree, it is logical problem, maybe a right way to describe it. So this is not a bug. I was thinking you were referring to something else when I previously said it was a bug. Must have been a different issue, but this is correct, yes. If you don't commit your changes, you may not be seeing them. And I think this is later on when we deleted something. Let me just move the chat out. Exactly. So this is no row returned because we have not committed. So I put this in the comment. Now after the commit, we get the right data. But when you delete it, this gets reflected immediately. So we're not, so this is an insert or update problem. It's not a delete problem. Yes. Okay, any more questions? Let me just stop my sharing. Stop shares here.
Is there a way to refresh the search index without committing the transaction?
That is this onStatement refresh, right? That's what I said. I'll take this as a work item and see if there is a way. Right now, I'm not sure it's out there. And even if there was, it might be quite expensive. So this is the other stuff I've shown in the last one, that you have all these internal tables. So if you do let me share my screen again. And so this is where I basically, you see this again? Are you seeing this?
Yes.
So yeah, so you have these internal tables, and I did. So here you can see by querying this $I table that you see that all these like dolphin, dog, cat, they're kind of extracted from the JSON and inserted as separate rows. And I've created this count column, which just counts the number of rows in these internal tables. So we saw that there were 47 rows. And then I insert my Dumbo elephant, and that one has like a longer description, like an elephant has a long nose that serves as a straw. Now if I commit it and I count again, I see that there are 79 rows. So from 47 to 79. So the one insert caused a lot of other inserts. So you can imagine if we have this onStatement behavior, that you have a lot of updates or insert happening on these internal tables. Whereas if you do it on commit, you can at least bundle them and do them together. So I'll find out if we have something like onStatement, but my assumption is that even if we have it, it won't come for free. It will come at some cost, significant cost. But I'll find this out. I mean, it's always good if we, if I take a work item and then next time we can follow up on this. let's do it this way.
And another question, does sync_index commit automatically? If not, then this is what we can use.
You can use the syncing methods. I mean, this is again, like last time I had Roger Ford on the call and he could answer all these questions. But sync index, you would still have to call explicitly, right? So it would still require you to do something. So instead of committing, you would have to do a sync index call, if I'm not mistaken. But you could do this. Yeah, you could force the syncing. I'm not sure if it commits. That's what I'm not sure. So I'll take this and have Roger take a look at these questions.